Okay, we're awake. 2 electrons. 4 electrons plus 5 is 9. Fluorine has 9 electrons, so that is correct. Okay, given the following electron config, identify the element and determine what this element wants to do to become stable. 3s2. Can I just go to 3s2 and go, that's magnesium and it wants to lose 2 electrons? I could have added it all up. I could have said 2 plus 6 is 8, 9, 10, 11, 12. 12 electrons is magnesium. Magnesium has 2 valence electrons. If it has 2 valence electrons, does it want to gain 6 or lose 2? It wants to lose 2 electrons. Oh, the element. Oh, sorry. I'm identifying the element, magnesium, and it wants to lose 2 electrons. See, now I'm falling into that same track. Not even reading. Okay, given electron config, put a square around the electron configuration that is most stable. Circle the configuration of the most active metal. Okay, most active metal is going to be down in this corner. The least reactive is going to end with P6, because all noble gases are 2, 2, P, 1, 2, 3, 4, 5, 6, 3, P6, 4, P6. So anything that ends in P6, that's going to be your most stable. And then put a circle around the most active. So this is S block. It's going to be an S1 is going to be the most active. So, oh, there it is. Circle. What is the oxidation number on an aluminum ion? All you got to do is look at your periodic table. Chlorine ion. Magnesium ion. +2. When chlorine forms an ionic bond, it would want to gain electrons to become a stable ion. How do I know that? Chlorine has 7. Does it want to lose 7 or gain 1? It wants to gain 1. That's where that -1 comes from. Does oxygen need to gain or lose electrons to become a stable ion? Well, again, oxygen is a non-metal. It's here. It wants to gain electrons to become -2 charged. So it wants to gain. And it wants to gain 2. Magnesium, gain or lose? Magnesium is right here. It has 2 valence electrons. It wants to lose those 2 to become +2. So it wants to lose how many? 2. When iron and oxygen form a compound, it is called, iron is a transition metal. So what has to be in the middle of this? It has to be iron 3, because it has to tell me what it's charged in the middle of the name, or I can't go from a name to a formula. So it's iron 3 oxide. Simple enough. What is the correct formula for copper chloride? Well, copper +1. They told me it was +1. It's a transition metal. Chloride, that's the Cl. It's -1. So that's it. -1, crisscross, done. What is the formula when aluminum and oxygen combine? Well, I have aluminum, and it is +3, right? Aluminum +3. I have oxygen, it is -2. Oxygen, -2, and then I crisscross, so the 2 goes here, 3 goes here, Al2O3. That is my formula. Name this compound. It's pretty easy to name them when they're ionic. It is simply the name of the first thing, and if it's an element, it is the name of the element with an IDE ending, right? Right. What is the formula for magnesium and the polyatomic ion phosphate? So I have magnesium, which is +2, and I have a phosphate, be careful. I had a lot of people today put wrong things because they just didn't read that that's an ATE, not an ITE. PO4, and it's -3. And it's -3. And then I have to crisscross. Now I don't bring this 2, I don't multiply this 4 by this 2. I don't bring the 2 outside of the, I put a parentheses, and that 2 goes outside the parentheses. This 3 comes down to the magnesium. So it's Mg3, PO4, 2. I hope that makes sense to everybody. What is the formula for the compound formed with magnesium and chlorite ions? It does not say IDE. That is not chloride. That is chlorite. So I need to be looking on the back. Chlorite is ClO2. It is -1. ClO2 -1. And magnesium is +2. So again, I have to put some parentheses, and that 2 has to come down, and that 1 comes down. And I am done there. Okay. Oh my goodness, this thing is so painfully long. What is the formula for silver +1 and the polyatomic ion nitrate? Okay, so I have Ag, and it is +1, and I have the polyatomic ion nitrate, which is -1, and NO3. Done. +1, -1, crisscross, done. What is the formula when zinc and oxygen combine? God, they're making this too easy. Zinc is +2, oxygen is -2. Oxygen is -2. Zinc is +2. Crisscross, done. They eliminate each other. Remember, we're canceling each other out now. Use the information data to create the formula and name of the following compounds. Copper 1 and carbonate. So it's Cu, and a carbonate is -2, and it is a CO3, and so it's going to be Cu2CO3, because that's +1, so we have +1, -2, crisscross, and the 2 goes to the copper, and that is copper carbonate. Aluminum and nitrate. So we have Al, and a nitrate, oh, I don't have to do that anymore, it's an NO3. And it is -1, and this is +3, so this has to go in parentheses, and it is AlNO3, and that is aluminum nitrate. I mean, come on, these are too easy. Ammonium and sulfate, so that's NH4, and it's +1, and a sulfate is SO4, and it is -2. +1, -2, so, oh, I need some parentheses. So it's NH4, oh, I gotta make some room here. NH4, 2, because that -2 comes down, this is +1 comes down here, and that is ammonium. Guess what? Sulfate. Too easy. Magnesium and sulfite. So I have Mg, which is +2, and I have a sulfite, which is -2, which is SO3. -2, so I'm done there, and that is magnesium sulfite. If you don't see how I got all these numbers or where these oxidation numbers came from, and again, we don't need to see those. Those aren't part of the formula. If you erase them after you're done, I don't care. That doesn't matter. As long as you crisscross correctly. I only care that the 2 is down here. I don't care that there's a -2 above this sulfate. So, covalent bonds, blank electrons to achieve an octet of electrons. They share. Ionic bonds. So ionic bonds, they take electrons. They do not share. They either take or give electrons to achieve an octet of electrons. I love how this is written. How do you get you think that should be a D? How do you get an octet of electrons for the atoms below? Well, sulfur has 6 electrons, so it wants to gain 2. And it will become an anion. Anything that gains electrons is going to become negatively charged, and if it gains 2 electrons, it's going to become negatively charged 2. Nitrogen wants to gain 3 electrons. The way I'm figuring this out, nitrogen is here. It has 5 valence electrons. It has 5 valence electrons. If it has 5 valence electrons, it wants to gain 3, not lose 5. It's easier to move 3 than it is to move 5. If it gains 3 electrons, it's going to be charged -3. That's an anion. Ca, all metals are going to be cations, I can tell you right now. And calcium has 2 valence electrons, so it's going to want to, it's going to want to lose 2. Lose 2. Cation, +2, +2. Calcium and magnesium are in the same row. Aluminum. Aluminum is going to want to, it's got 3, so it's going to want to lose 3. Cation, +3. Remember, aluminum has 3 valence electrons, wants to lose them to go to +3. It's cation. Name the following and show the sharing of electrons to achieve an octet of electrons. Oh my God, seriously? Okay, this is carbon tetrachloride. Oh, chloride, yes, chloride. And it's going to look like a C, a carbon with 4 chlorines. And if I put all their electrons around them, I told you how to do this, and I'm hoping that you won't have to do it on the test. But in case you don't remember, what you're doing is you're adding up the electrons. We'll do it on CF6. You can't even do that. You can't make that compound. There's no such thing as CF6. So showing the sharing of electrons, kind of impossible, because carbon can only share with 4 things. It only has 4 valence electrons. So yeah, that's not ever going to happen. I'm guessing they're just concerned about the naming and not the sharing there. Anyway, so this is carbon dioxide. And the way we figure out how it's bonded, carbon has 4 valence electrons. Each of these oxygens has 6 valence electrons. 6 times 2 is 12, plus that is 16. So I have 16 electrons to connect these 3 things together. You're going to put the one thing in the middle by itself. So I'm going to make connections and go, okay, that used 2, that used 2, that's 4. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But this only thinks it has 4 electrons, so that can't be it. So I'm going to add another bond. That's 2, 4, 6, 8. Now I'm going to add 9, 10, 11, 12, 13, 14, 15, 16. Now he thinks he has 8, 2, 4, 6, 8. He thinks he has 8, 2, 4, 6, 8. He thinks he has 8, 2, 4, 6, 8. Everybody's happy. That's how you show the sharing of electrons. This doesn't exist, but carbon hexafluoride, if I was naming it, if it existed in some form, you would have to have fluorines bonded to each other like this, and I'm not even sure that that would work 100% without some double bonds. Again, I don't want to go through the mental flip-flopping and confuse you on how to draw that, so let's just not. This is hydrogen. Ooh, this is dihydrogen monoxide. Okay, also known as water. Can we just name it water? We're just going to call it water. Oh my goodness. So far to go. So far to go. I guess I'll work on another video.